In the lesson on creating a control chart to monitor the standard deviation, the b-factors were taken from a table. In this lesson, we will show how to calculate these factors. And hello again to this lesson, which has only one learning objective. After this lesson, you should be able to calculate the b-factors yourself for different sample sizes and non-interference probabilities. Let's start the calculation of the b-factors for standard deviation charts. The warning limits have a non-interference probability of 95%. The control limits of 99%. As can be seen here, the warning and control limits are calculated by multiplying the standard deviation by b-factors. For the sake of simplicity, these values are usually listed in tables, but will now be calculated by us. In the table on the left, in the first column, the b-factor has been replaced by a formula that can be used to calculate these b-factors. This is exactly what we will do step by step in the following. As we shall see, these factors differ depending on the limit to be determined and also dependent on the sample size. Let's start with the control limits. The probability of non-interference in the process should be 99%. This means there must be a range between which all values will be located with a probability of 99%. Thus, 1% of the values are outside this range. The size of this area is denoted by alpha. The area under the curve represents 100% of all values and was set to 1. Thus, the area within the limits has a size of 1 minus alpha. Since there is an upper and a lower limit, the values outside the limits are divided into alpha halves. For distributions such as the nominal distribution or the chi-square distribution used here, these limits are only listed in tables for one-sided limits. Therefore, this transposition here must first take place to a one-sided limit. Thus, alpha halves are left outside the limit and 1 minus alpha halves are inside the limit. So 0.005 outside and 0.995 inside, or 0.005 on the right and 0.995 on the left. The Excel function chi_sq.inf.rt can be used to calculate the various quantiles of the right-hand chi-square distribution. But before we do that, we want to do that first with the help of a table, as you would usually find in the relevant literature. This exercise is also important to prepare for the calculation with Excel and what is meant by the right-tailed chi-square distribution. The value distribution shown here is divided into two halves. The blue part on the left and the yellow part on the right, labeled alpha. For this alpha proportion on the right, the quantiles are tabulated, representing the limit on the x-axis. Hence the name of the right-hand chi-square distribution. So if you are now looking for the quantile, this means the limit or the cut point behind which 0.5% of all values are, you first look for the 0.005 in the table for the chi-square distribution in the row for the different values of alpha. Then you go to the line for the corresponding degree of freedom. This is calculated from the sample size minus 1. So here 20 minus 1. The corresponding quantile can now be found at the intersection of the degree of freedom 19 and alpha 0.005. Here the value is 38.58. Just as we have determined a quantile with the help of tabulated values, we will now do the same thing, only this time with the corresponding Excel function. Please don't get confused at this point. The formulas for the factors refer to the original non-interference probabilities with 2 limits and not to the one shown on the right with only 1 limit. Let us first calculate the quantile for the upper control limit for a non-interference probability of 99%. The Excel function for the right-tailed chi-square distribution requires 2 values. First, in the probability field, the probability of alpha, here 0.005, and the degree of freedom value. For a sample size of 5, this value is 4. This results in a value of 14.86 for the quantile. For the lower control limit, there is now a small contradiction in the naming of alpha. For the lower limit, alpha becomes 0.995. From the original naming, this would be 1 minus alpha. However, since we are calculating in the system of the right-hand chi-square distribution, alpha must be 0.995. So, in the first probability field, enter the probability of 0.995 for alpha and 4 again for the degree of freedom. This results in a value of 0.207 for the quantile. So, now that the values for the quantiles of the chi-square distribution are known, they can be put into the formulas and the b-factors can be calculated. As can be seen in the last line, the b-factor for the upper control limit has a value of 1.924 and the b-factor for the lower control limit has a value of 0.227. It is these b-factors that can be found in the corresponding tables as excerpted below. For different sample sizes, there are logically different values for b. The table has been supplemented accordingly. The b-factors for the control limits were calculated for a non-interference probability of 99%. If the probability of non-interference changes from 99% to 95% for the warning limits, then the b-factors also change. As shown here, the tables for calculating the limits of a standard deviation chart therefore contain different b-factors for the lower and upper control limits and for the lower and upper warning limits, depending on the sample size. Well, that was only one chapter, but possibly a lot of new information. Therefore, I would like to conclude by repeating the 3 most important key messages. The b-factors are calculated using the chi-square distribution. The chi-square distribution is asymmetrical, so the factors for the upper and lower limits are different. The quantiles of the chi-square distribution in tables are only for one-sided limits, or are calculated for such. If you found this lesson helpful, please let me know and leave a comment. Thank you for that, take care, and see you next time. Bye!